we've got a quarter of an hour left. I'll go through this relatively quickly. I think I should probably be able to cover what I was roughly going to talk about. If there's anything missing, I'll catch up with that after afternoon tea. So I do intend to stop on time. So I was really just going to talk about what's Open Radio. And I thought we needed a little bit of background. I know most of you are amateurs, so we'll skip through this fairly quickly, especially if that works. So we sort of had digital operating modes. In some ways, Morse code, at least when you got to valves and continuous wave, was digital, although it was really treated as analog signals all the way through. People generated it the same way as you generate analog stuff, and they listened to it to receive it. Then there was some radio teletype that starts in the 1920s, valves and relays and that sort of stuff. Didn't change very much really until after the Second World War. So they had the RTTY and stuff like that. It just got better, but the same technology just improved a bit. And then all of a sudden, stuff happened with transistors and integrated circuits, and they replaced the valves with microprocessors eventually. But they're still doing the same RTTY bit at the back end with the same modulation. Then they started taking the things from the telecommunications industry, like X25, and we came out with a thing called AX25 and several other things. So that was the beginning of the packet modes. That was in roughly the 1980s. So there's a bit of history on digital. Voice, well, we started out with AM, and then as far as amateurs were concerned, everything sort of changed and people just stopped using AM, even though you still get it on most radios as an option. No one uses it. They either use single sideband or FM. Why? Well, single sideband chops 2/3 of the signal away, throws it away and just uses the bit you want. So it's more efficient band-wise and power-wise. And works. And FM, well, it was quieter and it works. And those between them took over most of the operating modes that amateurs used for a while. The next big change is happening is digital voice, and we'll be talking a little bit about that probably after afternoon tea, maybe just a bit. So in the beginning of stuff, everything was open. People shared their designs. Even if they didn't share it, if you got a valve transmitter, you could see the design. You just had to go and have a look and you could see what they'd done because everything was visible. You could inspect things. That continued with discrete transistors, even into the early integrated circuit days, because the ICs only did small things. You know, the sort of first things you had were audio amplifiers and power regulators and things like that. Then we started having bits of digital components to do switching and little things like that, but it was all stuff that you could work out. The components at that stage were all well documented, and commercial equipment usually had a really detailed circuit diagram. It probably had the PC board layouts, and it probably had a description of how it worked, at least in the service manual, because people needed to service the things. And then things got changed. So we got proprietary stuff happening. We've got people just deciding not to do things, and then things got worse with patents, and even worse with that were the software patents. So things became dependent on software, and we got exactly the same issues in the open radio or open hardware space as you have with open source software and patents. And then the really big change started to happen. Instead of having discrete components, we said, I can do all that in software, as you've heard earlier today. We started using the sound cards in computers to do modulating, demodulating. We started using other chips to do stuff, microprocessors built in there, as you heard with B-Dale this morning. You can get everything on a chip. Sometimes they're reasonably open, sometimes they're totally closed. Often they're partially sort of open with really restrictive licenses which don't suit the open source movement. So I think open radio means having the same freedoms as open source software. Happy to debate that or whatever later on this afternoon, but that's really the sort of the definition I'm trying to with and encourage. Now, let's have a couple of examples. The TAPA stuff. So the Tucson amateur radio people, a long time ago, in the 80s, produced kits, and they still produce kits. If you go to their website, you'll find a whole lot of stuff that's around software-defined radio, and what they're trying to do is build a complete stack of bits and pieces that all integrate together to solve the problems that we've got as experimenters with radio. Oops, I should have said Blade RF, I got that wrong. The product that was just mentioned before and another product called Hack RF, they're both very similar. They are a board that will go from somewhere in the HF region up to about 6 gigs, interface to your computer with the USB, I should say, and just do stuff. They were both launched on Kickstarter. And Raspberry Pi and Whisper is another little interesting thing. Put some software on a Raspberry Pi and a piece of wire, and you've got a very low power transmitter for a particular mode. You will have to go and filter the stuff going out of it because it's pretty noisy, but you're just going to put some sort of filter on it. That's really a toy, but people do use it. But it sort of illustrates what can happen. There's Hack RF. I'm not going to play the video. It's, as you can see, raised over $500,000 US. He actually got his Kickstarter amount in 6 hours. That's how much people value open hardware and open radio stuff. Circuit diagrams are all up on the web. That's part of the circuitry for it. That's just saying it's there. So the goal with that project was to put everything out in the open, so the casework, the circuitry, the software will all be up there for people to do stuff. As far as I'm aware, the only thing that Mike is keeping proprietary is the board design. So he's got a multi-layer board. He will keep the actual design of the board layers proprietary at least for a while so he can get some revenue. But you could go and build one yourself if you wanted to. Now, one interesting little fact that came from his work on this project is the layering in the boards. The manufacturer produced the board with the layers in the wrong order, and when he went and assembled it, he had problems. The performance was a lot worse than he expected in one area. Eventually had a look at the boards. Oh, got a new set, works perfectly. So there is lots and lots of things that are important on these things, remembering that it's working on that huge frequency range. Oh, that's the Raspberry Pi thing. So you've got, as I said, you've got an antenna thing up here, and there's some filtering to make it so it's reasonable. I finished early with the quick lot of slides. Righto, so we can break now. You can ask questions.